Okay, we've moved back to our polarized light. Now, we describe these filters as letting light through that is polarized in one plane only. And that is actually what's happening. But we can still see an awful lot of light coming through. It isn't removing anywhere near as much light as we would expect if it is working as a filter to allow just that plane of polarization through. So why? Why do we see so much light and so much microwave coming through the microwave filter if we are saying it only lets light through in one direction? Well, the filters are sort of changing the direction of polarization. The outgoing wave is just oscillating in one direction, but it is also, as well as just filtering out these, or just letting through the light that is already in that direction, it is taking the vertical element of light that is in other directions. So it has a small vertical element if it's vibrating in that direction, and is letting light through in that direction as well. So the intensity of light coming through is actually equal to the cosine squared of the angle between the light hitting it and the original direction of the Polaroid filter. So if we put a second filter in, the amount of light that is letting through is cosine squared between this filter, the angle of this filter and the angle of that filter. So at 45 degrees, this filter is letting through half the light of this filter. The cosine of 45 degrees is about 0.707, and 0.707 squared is 0.5. So it's cutting it down by half. And then remember that the light coming through this filter is only coming through at 45 degrees. So if we put another filter in front of it, it's cutting the light down by half again. So that's cutting it down. The original amount of light, the intensity, is being cut down by the pair of filters by a quarter. If we have the cross polarizers, put that in, again it's a quarter of the light coming through that filter because the filter is changing the direction of polarization of that light. The filter in the middle is changing the direction of polarization. And this is Malus's law. And if you knew that, you're a knowledgeable physicist, a really good physicist, and with a good understanding. But you might be a quantum physicist and think about it in a different way. Quantum physicists that might talk about the probability of an individual photon of getting through the filter. So the probability of all of that scattered light, a proportion of that scattered light getting through, a single photon coming from the light bulb has a 50% chance of getting through this filter. If it is at 45 degrees, it has a 50% chance of 50% of getting through this one. And if we then have that filter, it's got 50% of 50% of 50% chance of getting through all three. So, hope you've enjoyed our Christmas puzzle and my challenge on polarization. Happy Christmas.